Looking at question 1, part A, and moving on to part 5. What is the interquartile range of weights of packets of frozen peas? Now first we need to know what is meant by the interquartile range. If I draw a graph of a normal distribution, then in fact the interquartile range is the middle 50% of the peas. So if I shade this area here, this will be 25% in this area here. And if this is the mean right here, exactly in the middle, the mean, which has been given to us, at the top here, mean weight of 1.1 kg. So if I write that in, 1.1 right there, and I know also that another 25% shaded here is likewise above the mean. So altogether the shaded area is 50%, and that is the interquartile range. But I don't know the lower boundary and the upper boundary of this interquartile range. Those are the boundaries that I need to work out, the lower boundary and upper boundary, in order to answer the question. Unfortunately, with the calculator, this particular calculator, does not take an input, lower boundary and upper boundary. It just takes one input. That one input is the upper boundary, and there is no lower boundary. In fact, it just goes forever to the left, as if it were a very negative number over here. Although you don't enter that in, the calculator just assumes that you're shading the entire area. So I'll have to shade in the area that the calculator will work out. The calculator will also work out this area here. So we are going to have to work out this area here inclusive as well, even though we don't want it. And we're going to have to take it away and subtract it after we work out what it is. And then we're going to be left with this middle 50%. So this area here is 25%. We've got 25% shaded here, 25% here, 25% here, and the very top is another 25% to make up 100% for the whole graph. So the first bit here, shaded very well, is 25%. Let's enter that into the calculator. 25% into the calculator is going to be entered as 0.25 as a decimal. You must enter it in as a decimal. So let's see how we do this on the calculator. Let's go to the calculator here, and we'll turn it on and press menu and stat. And we'll go to distribution and normal distribution, inverse normal, because this is an inverse normal problem where you're trying to work out the boundaries. You're not given the boundaries, but you're working them out. Inverse normal. So this is inverse normal, and what you need here is an area. So the area, let's put that in, we just work that out. We're trying to work out this area here as a decimal. It's 0.25. You just enter that in. So 0.25 EXE, and standard deviation, that sigma symbol with a little dash above a 0. That's what it looks like there. Standard deviation has been given here. Standard deviation of 0.1 kilograms at the very top of the question. Use that again, which we've been using throughout the question, or throughout the little parts of the question. 0.1, and the mean is also given at the top of the question there, mean weight of 1.1 kilograms, so we enter that in as well. Okay, so we've got the three things that we need: the area, the standard deviation, and the mean. Press X here again to get the answer, and that is the answer, 1.0325. 1.0325. Okay, so we found our lower boundary there. That's the lower quartile there. Now we need to know the upper quartile. Well, the upper quartile is going to have to be entered in to the calculator as 0.75. Why are we going to use 0.75? Well, all of the shaded area here, the whole, all three bits, this first bit here is 25%, 25%, 25%. Altogether we have 75% shaded, and as I said, on this calculator you must have a lower boundary way down here, and you don't even enter that into the calculator. The calculator always takes that as a lower boundary. You can only enter in the upper boundary for the calculator. So we are taking this as 75%. This mark here is a 75% mark, just here. All right. So we'll enter in 0.75 into the calculator. Let's exit here to go back to this here and change 0.25 to 0.75. Press XE and then keep the mean and the standard deviation the same. Press EXE again and we get 1.1674. Okay. So we know here this value here is 1.1674. Okay, we have two values here now, the lower boundary and the upper boundary, which specify our interquartile range. Okay, if you want to know exactly what is between these, the amount that is in between these, you will have to subtract them. Okay, so we could just do that on the calculator and enter that in. And so I'll go to the menu on the calculator and press 1, and I can type in that upper boundary that I found out there, the upper 75% there. So 1.1674 minus 1.0325 equals, okay, so the answer is there, 0.1349. So I've entered that in there. Interquartile range equals, okay, and you might want to just enter in some of those other things there we've got as well. We've got the lower quartile, which we've worked out to be 1.0325, and we've got the upper quartile, which we worked out over here as well, is 1.1674, and I think we should write in some units here as well, kg, 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 and how many decimal places? 4 decimal places, 4 decimal places, and 4 decimal places, okay, just to be safe. And those are your answers there, just to give all the information that the examiner is looking for, interquartile range, and where the lower quartile and upper quartile were, showing a little bit of working as to how you worked out that interquartile range. You just subtracted them.